Hi, everyone. Welcome to this exciting session hosted by Build AI Kenya. We're a dedicated community that brings together professionals and enthusiasts to explore the world of artificial intelligence and data. Our discussions span various topics, including frameworks, legislation, and much, much more. We hold these insightful sessions monthly, typically in the last Monday of the month. Just a few etiquette and guideline rules. Please mute your microphones. Please keep your microphone muted to avoid disruptions during the session. Engage respectfully. We kindly ask everyone to remain respectful and considerate throughout the session. Use the Q&A section, which you should have access to. You can ask your questions in the Q&A section. And if you want to ask questions to the participants at the end, we'll have a Q&A live session at the end where you can unmute and actually ask Bethany questions. Try and limit distractions. Participate actively. So feel free to post questions on both Q&A and keep your live questions to the end. If you have technical issues, there should be somebody to be able to help. So if you use the chat function, you should be able to reach out to somebody who will support you. The meeting is going to be recorded. Please note that we record the sessions and we typically post them onto our YouTube channel. So if you're against being recorded for the session, feel free to drop off now. This week, we're thrilled to have Bethany, who's a cloud advocate at Microsoft, leading today's session. Bethany is passionate about data science, artificial intelligence, and machine learning. She actively engages with aspiring developers, entrepreneurs, and business leaders to facilitate learning and growth in AI. Today, Bethany will be discussing generative AI in Azure AI Foundry, and we're excited to dive deep into this topic and learn from her expertise. Please join me in welcoming Bethany, and I now hand it over to you, Bethany.
Thank you so much. Let me start by sharing my screen. And as Michael has, I hope you can see my screen. As Michael has mentioned, the session is all about Azure AI Foundry. So what can we be able to do in Azure AI Foundry in regards to generative AI? What the session will typically involve is basically the building blocks of building an end-to-end solution. I wouldn't go into the technical bit of it. I'll try and showcase more of the demos, like the output versus doing the code bit, but I'll also share the resources after the session. So you can be able to go in and figure it out, play around with it. And in case you have developers who might want to build and extend their own copilots, you can be able to do so at the end of the session. As he's mentioned, I'm Bethany Jepchumba. I'm a cloud advocate at Microsoft. And my role typically includes working with developers as well as the product groups in Microsoft to ensure you have a smooth sailing when you're building AI solutions. And that's why I'm talking about generative AI solutions on Azure AI Foundry. And you can reach out to me on any social media platform, either at Bethany Jab or Bethany Jepchumba. Those are the two names I use. So in case you want to reach out to me after the session, you can feel free to do so. And then the last bit is if you have any question as you continue the session, be sure to post in the Q&A section of this chat and I'll be able to answer them as we continue. So let's get started. As I've mentioned, I'm Bethany. Oh yeah, and you can find my blog at bethany-jep.com. So the reason why we're talking about Azure AI Foundry is because we have a set of solutions on Azure, including all these different Azure AI services that you can see, including the Azure AI services, which are our main AI services. This includes things like how you can be able to use custom vision or language. These services were there way before generative AI came in. And the idea of these AI services is they help you just get an API key and use it in your own solutions. So they're already pre-trained and you can be able to use them to add intelligence into your applications. And then we have Azure Machine Learning for those who are interested in building end-to-end machine learning models and playing around with them. Azure Machine Learning is a platform for you. As you've interacted with AI, I am pretty sure you've noticed we need a lot of responsible AI around. So again, as part of the Azure AI catalog, we have the responsible AI tooling. These are ingrained in each and every of our AI solutions, and you can be able to even add additional responsible AI and trustworthy features. And then the last bit where we'll be focusing today is Azure AI Foundry. And what Azure AI Foundry does is it gives you an end-to-end solution where you can be able to view the model catalog. We have about, I guess, 1,800 models available on Azure. So you can view the model catalog depending on the tasks you want to perform and what you're building. You can be able to select the different foundation models available, either open source or even those that are specific to your task. And once you select your model catalog, you can bring in your own data and then use Azure AI Search to be able to index your data. I'll talk more about what indexing is, but Azure AI Search will help you now be able to go through your data and get an output from it. And then we have Azure AI Agent Service, which now comes in and helps you to build agents. Agents are autonomous AI applications. What this means is you can be able to use agents to basically go in there and do tasks for you, right? They are smart and they can be able to do things on your own behalf. And then, of course, as I mentioned, we have responsible AI features, including Azure AI Content Safety. This is now where you're able to add in responsible AI into your solutions. And once you build your own solution, you can go ahead, evaluate, and monitor once it's in production. Basically, observability, where you can be able to now see, okay, my code is in production, how can I be able to evaluate that it's doing what it's supposed to be doing? And then Azure AI Foundry works with the tools that are already available. So you can use GitHub, you can use Visual Studio, you can use Copilot Studio to be able to extend now your own application, depending on what you need to add in there. Today, we'll talk a bit about GitHub, we'll talk a bit about Azure OpenAI, Azure AI Search, and evaluations. Okay, so first things first, Azure AI Foundry. Let me go to the Azure AI Foundry page. Yes, so this is the Azure AI Foundry. I won't show the overview because that's where my keys and endpoints are. But then I can be able to share with you everything else here. So this is Azure AI Foundry. As you can see, it has a lot of tools to get you started. The first thing is the model catalog. So when you're building your generative AI application, the first thing for you to decide is, yes, you're building a generative AI solution. So you need a model, either a large language model or a small language model to be able to help you based on the tasks you want to do. So you can come in here and basically filter your models and also compare your models and see which one is best for your use case. So for example, if you choose GPT-4 Mini, you can be able to see why is this model, what does this model do, and why should I use it? Let's wait for it as it loads. But basically, it will be able to give you a benchmark of this is the model you want, this is how you use it, and so much more. Yes. So you see it has benchmarks where you can be able to compare it with other models and see, is this really the right model I want to use? Then it also gives you the evaluation in terms of probably this is how much it will cost you if you want to use it. And then this is the quality. So this is over one, like technically 79%. So it gives you the quality index of like, yeah, this is the quality you expect of the output. And then this is the duration of time it takes to give you the first token and how many tokens are generated per second. Basically, the human reading speed is like 100 tokens per second. So at 73, that's pretty much good enough for your use case if you're using it for humans to read. And then that's essentially it. You can be able to now go in and see, okay, this is the model I want to use. And then once you've been able to say, okay, I've deployed this model, this is the one I want to use, you can still go in and experiment with it. So you can use, for example, the chat playground. And I'll be using GPT-4o. Let me wait for it to start. So I'll use GPT-4o. And then I can ask a simple question, right? But to be able to now ensure you're interacting with the models, I'll talk about this more. You can add system message, you can add in your data and different parameters. So the easiest thing I can do is just to use a prompt that's already there, invent a recipe for a dish that combines flavors from 2 different cuisines, and that's the output. So you can go in and see, okay, this is what the output is, evaluate. We'll dive deeper into this and how you can use all these tools. And then once you evaluate and see, okay, this is the model I want to use, you can then go either build using code or using prompt flow. Be able to now build an end-to-end solution. And then, as I mentioned, we have AI services. So if you want to use any other AI services other than the LLMs, so like, for example, vision, language, or speech, you can be able to find them under AI services. This is a new one, the agents. So if you want to be able to get in and build your own personal agents, the beauty of agents is, let's see if it will work. The beauty of agents is you can be able to add in data either from the Bing Search API or your own data, and you can be able to create using things such as Azure functions so that it can be able to do tasks for you outside. It can be able to do tasks for you outside what you normally do. So with agents, what you do, once a new agent is created, you can come in and add in knowledge. So from Fabric, from SharePoint, from Bing, or Azure AI Search, and then you can give it things to do. So can it read code? Can it probably give you a structured output and so on and so forth? So that's about agents. And then fine tuning is mainly about optimizing your models. So once you've selected a model, you want probably to have it work to your specific domain. So you use fine tuning for that. And then we have tracing, evaluation, and tracing and evaluation. Let me talk about those two. Tracing helps you be able to detect in case you have any bugs. So how can you be able to fix it? I'll show you that in action. And then evaluation would be this one, where I'll show you how I created this. But what evaluation does is it gives you an output in a graph format of like how your model is performing. The scores are out of 5, so it's pretty much good. But basically, it gives you an output of how your different applications are performing. And as I mentioned, safety and security, this is where the responsible AI tooling is. And in here, what you'll see is the different ways to be able to either measure the risks, manage, and mitigate in case there's any risk coming in. How can we mitigate it? So you can use things like content filters. A content filter will help probably prevent any harmful content from there, sexual content, any content that promote abuse. So the filters are already put in place, but then you see most of the filters are default, which is probably medium. But now, depending on the audience that you're working with, you can be able to now add in probably to a high rate or low, depending on now the use case of your application. So this ensures all your models are safe and secure. And then down here is my assets. These are basically what you've deployed, so the models you're using. If you add in your data will be here. And then if you create a web application based on your application, you'll find it here. Okay, I've talked a bit much about Azure AI Foundry. So let's talk about prompt engineering. I'm pretty sure all of us here might have heard about prompt engineering at one point or another. But the reason why we do prompt engineering, that is, we're able to add in enough context and give our LLM enough details to be able to give us a response that's fine-tuned. The reason we do that is because, one, models are stochastic. Stochastic just basically means they're random. So when you add in a question, it will generate an answer based on a probability, a list of probabilities. So for you to be able to get the highest probability, you need to ensure your prompt is tuned to the best level you can be able to tune it to. And then generative AI models also fabricate responses. This means since they don't understand really what the output is, they might just give you an output based on what the data is being fed to it. And some of the time you'll realize it does not have data of current events. So instead of it giving you like data of current events, it will probably fabricate and try and give you a response based on that. And then the other bit is if you don't give it enough data, it does not have memory. So that means it cannot be able to infer from its memory and give you an output. It needs context to be able to read, to be able to give you a response. So that's why prompt engineering is important. And how we do prompt engineering is one, we give it a system message. So you give it a task that it's supposed to perform. And then the next thing is you go in there and edit the parameters that are available. And now you ask the question, then you get the final output. So I'll do a short demo on prompt engineering. But before I even do the demo on prompt engineering, I don't know if anyone has any question. I'm not seeing any question on the chat. So I'll assume everyone is following. Okay. So a demo on prompt engineering. As you saw, this is just a recipe for a recipe from two different cuisines. So it's Mexican and Indian cuisine. But then what we'll build in this session, let me show you the output. We want to build a website copy generator. So we want it to be able to use our data to generate copy for our website. So for example, our data is about Contoso, which is an outdoor company that gives tents and everything. So this is an example of a copy that was generated based on the question that was there. So we can ask a different question. Instead of a tents catalog page, you can ask, for example, for the hiking boots catalog page. And once we get the response, you see it's using some context and then it's generating copy based on the context used. So it will take a while to generate, but you can see it's talking about hiking boots catalog. And then from the data, it can be able to read, we have the trek ready hiking boots. So there's the trek ready hiking boots. We have the other, it's trek ready, no, that's the same. Oh no, it's just using the data from Trek Ready to be able to now give us the website copy for that. And it's even giving us the customer feedback and everything based on that. So what we're doing is we're using data that we have, feeding it to our application. And then once we ask a question, it will generate a copy based on the data used. The data basically is the system message that we provided it. So here you can add, let me show you the system message that we used. This is without adding our own data. So the system message we used was, you're a web copywriter for the Contoso e-commerce company, and your goal is to generate the website copy for the homepage. The answers should be brief and engaging, and also show the word Contoso in capital letters. I'm not sure if it's, yeah, you can see Contoso is always in capital letters, always in capital letters. And then we've also added a safety copy to ensure it always sticks to the subject of the company and the product it offers. It doesn't add any controversial opinions and anything else. So if you ask a question, for example, for it to just create a business description for us. So this is an example of using reasoning, by using chain of thought reasoning, where we ask it to take a step-by-step approach to generate a welcome message for us, a brief description for the business, and the description of the product categories. And what we offer is clothing, sleeping bags, backpacks, and tents. So we can be able to send this, and it will take a step-by-step approach. It will tell us, okay, this is what I'm supposed to be doing. So one, I'm creating the welcome message. It should be warm and inviting to make the customers feel at home on the website. And then we have the business description, and then it tells us what it's about, same to the product category. And then at the end, it will say it's ending with a call to adventure. That's probably the call to action for our website. And then this is now the output that it's given us. So it's pretty much covering all the areas we've specified it to cover. So a welcome message, and then the product, and lastly, a call to adventure. And then if I ask it about a question probably around an election, it should not respond to me, right? Should we try it out? So like, what are your opinions on the just concluded election? I don't know which election just concluded, but I'm hoping there's one that concluded a few months ago. So we're asking it about that concluded election. And you see, because we added in the safety message, it will tell us, I'm here to assist only with creating engaging and professional copy for Contoso Outdoor. And that's the only thing I can be able to do for you, right? So that's basically how you use prompt engineering to be able to now custom tune your application to and build it in the format you want to, in a format that one includes safety, can also include the tone and behavior, and lastly, you have the task for it. So let me go back and show you again the idea behind this, which is the system message where we have given it a task, a tone, safety, and then we'll add context. Don't worry, you'll add context, but that will be in code. And then, of course, it will use the conversational history as part of the context. And then the other thing we can change is temperature. Temperature basically helps you come up with the idea around more creative prompts. What it does is it makes the probability of selecting anything higher. My temperature was already high. It was at 0.7, so let me put it to 1. You can increase the temperature past 1, but because Microsoft basically is a business company, I don't think if you included past 1, it will give you the response that is legible. So we'll just put it at 1. And then we can ask a different question. The question we'll ask will be probably a tagline. So we ask about a tagline and ask it to generate for us a tagline. Let's see the output it gives us. Gear up, explore more, adventure wait. So you can ask, give me more creative examples. And the idea will be, it will now give me different ideas of what I can be able to use for our tagline for the website. And then the last bit probably about temperature. If I ask it to generate for me a UI, I shouldn't have the temperature that high, right? I should reduce the temperature to make it as accurate as possible, for it to just take the one response with the highest probability. So I'll reduce this and I'll ask it to generate a UI for the e-commerce landing page. And because I have a hand-drawn sketch, I'll do that. I'll look for that sketch. I hope I find it. I'll look for a sketch on this and be able to upload it and use it for the website. Yeah, here's the sketch. So I'll use this sketch and upload it and see, can it be able to give me a better a response on this? So we'll test it out, right? Because we're asking it to generate code for us to match what I've just uploaded. It's generating the code for me. So you can see it's even using the Sky Person to view tent, as I'm pretty sure I've written the names, right? Sky Person to view tent and everything. So let's wait for it to complete. Wait, oh, the maximum, this is another parameter you can use. The maximum response was set to 800. So once it reached 800, it cut off. So I'll need to repeat it again. So I'll ask repeat the code again. Code generation. And then the idea behind it will have increased the tokens. So I'll expect it to now complete because I had limited the tokens. So let's wait for it to conclude. And then we can be able to test it out and see, is this really a response we can be able to use in production? Okay, so this is completed. So I'll just copy the code, come to my code base, probably create a new file. new file, example code.html, and then paste that response. And I'll need to go live with it. So I'll need to switch to VS Code. I'm switching to VS Code because I'll need to have the code live. And I want to go live. It should open a new page, right? So it's basically similar to my example that I uploaded. Let me show you the example. This is the example. Controls are auto company, the tents, the backpacks, and the hiking clothing. And this is the output, right? Pretty much good, right? It's pretty much giving me the output that I expect. And what I did was increase the max response, reduce the temperature, as well as the top P to make it more accurate. Okay, that's it about prompt engineering. So let's go in and add in our data. And the reason we add in our data is, as I mentioned, an LLM does not have context of your own data. So you will need to add in your own data. But then we have problems when you add in our own data. Different companies have a lot of data, and it's in a very complex manner in terms of you might have data in SharePoint, the data you might have is in probably Azure Blob Storage, the other data you have is online. And then also, as I mentioned, AI does not have access to the latest data you have because it's a pre-trained AI, basically. So since it's pre-trained, it might not have access to the latest data, and also it does not have access to your internal knowledge. So that's why we add in data. And the process of adding in data is called retrieval augmented generation. This is normally a tricky topic to explain. So let's see if I can explain it well. So retrieval augmented generation is how data scientists something very literal. Retrieval basically means you go in to your already available data and query the data. Once you query the data, you augment it. So augmenting is basically adding that data to your prompt to just enhance the prompt to use data that's already provided. And then now it generates the data. That's query the model and generates the data. So when you ask a question, what happens this is like the backend. Behind the scenes, let's go back to our example as I explain this. As you query the data, and this is our example, as you ask a question, right? So what happens is the LLM goes into your data and gets the data. This is the data that has been retrieved, such a long context. And then now the prompt and this data is now sent to the model and it comes back and gives us an output. So this is the generation. So question, retrieval, augmentation is adding both of this and then getting the response. That's how you can be able to add in your own data. And how this process works is you can use different ways to add this, right? But behind the scenes, what happens is when you update your data, when you upload your data, for example, to Azure, the first thing would be to chunk your data using different resources that you're using. So chunking helps now break down the data into understandable pieces. So let me go back to my example again. And you can see there's a place. Let me see if I can get it. There's a place that here, URL product 4MD. And then there's also, product 11 markdown. So this means our data had been broken down. So we didn't add in just one markdown file with all the 20 products of our company. What we did was we broke down into different products. Each markdown file has a different product. So when we're retrieving the data, it doesn't have to go through the entire process of looking at all the documents, but just looks at the specific documents and retrieves what is needed. That's chunking. And once you chunk, the next thing you need to do is vectorization. One thing about LLM models is these models are basically still statistical models, meaning you will need to convert your data into vectors and embeddings for it to be able to understand your data. So once your data is chunked into, probably for myself, it was separating the product into different files. And then once that is done, it's vectorized. So it's converted into embeddings. Once you get the embeddings, ranking is done. What ranking means is it now sorts the data probably based on how one will query it. So an example would be if I asked the question about tens, it will probably look for any database that has the word tens and probably rank it based on the question that was asked. So if it has tens, probably that's something an LLM can be able to extract from there. And then the last bit is indexing. Indexing is the same thing, similar to catalogs, where you can be able to order your data. Probably, for example, in a library, what happens is if you want to look for a book in a library, the catalog has probably the sections divided by an author name or divided by the fiction or non-fiction, romance or young adult or dark academia. So when you enter a library, you can literally go to a section that is, it's ranked based on the section. So you can probably go to the, let's say, dark academia section. And then in that section, you might be able to see the books ranked probably by author name or by the name of the books. So that's basically what happens behind the scenes. You won't have to know all these things, but I'm just telling you what happens behind the scenes before you now get the output. And you can use Azure AI Search for the indexing of your data. And then you can use the different Azure databases to store your data. So you need a data storage which has vector storage capabilities in there. And then you'll use Azure AI Search for indexing. And a disclaimer, because I guess we normally get a lot of questions on, oh, can I be able to upload my data on Azure? Will Azure use my data to train the models and so on and so forth? So a disclaimer is once you upload your data, it's in your own it's in your own resource group, it's in your own subscription. So your data still remains your data. The same way you use SharePoint and it's just your data, no one else has access to it. So your data is your data, and then your data does not get used to train the AI model. So the AI models don't use personal data to train them. And then the last bit is your data is protected because I guess as Microsoft, the initiative we're currently running is the Secure Future Initiative, where we want to ensure, one, it's secure by design, secure operations, and security is basically the fundamental bit of every of our AI applications. And lastly, just by the way, Microsoft uses Azure AI in their own tools. So it's something that you can just know at the back of your mind. And then to simplify the implementation of this in code, I used it's very interesting how to explain what Prompty is, because basically Prompty is a collection of the specification, the tooling, and the runtime, where you can be able to add in your prompts, add in your system message, add in your model configuration, and be able to use that in your code, whether you're doing Python, C#, or different frameworks. So Prompty comes in to help you bring the playground into your code. So this is how a Prompty file looks like. And as you can see, we have the name and description and author, and then we have the model configuration. I guess this is the most interesting bit because you've seen me, basically in Playground, you don't need a lot in terms of model configuration because the model is just there. But when you're using it in your local code environment, you'll need to explain which type of model you're using. So you can use OpenAI, GitHub models, or Azure OpenAI. In this case, we're using Azure OpenAI. And then the API is a chat API. And then now we've added in our app deployment that we're using. Then we've edited also the parameters. So I can increase the temperature to 9 because we want it to be creative, right? It's supposed to be our website copy generator. And then context is now adding in our data. So context in the playground will be this parameter where you can add in your own data. So I already have an index already here. So you can add that and interact with it on chat, right? Let me just use it as the way it is. And then you can be able to come in and interact with it on chat. So that's also the same thing I've added there. And then the last bit is now your system message, which is all this. As I mentioned, you have the system message, which is now the task, what you want it to do, the tone, you want it to be concise and engaging, you want it to be friendly. And then you've also added in the safety measure. Then the last bit is now providing context. We do, as you've seen the output, we have the context we've provided. And then when a user asks a question, they can be able to get a response. So in our case, we've added in a context here about the Skyview tent. And then the question is create the website copy for the tents catalog page. If I run this locally, it will be able to give me an output, right? The 2-person tent. Don't be afraid of code. It's just very easy. But then it gives me an output of, okay, this is a contoso tent, and this is what it's all about. And that's it. So once you have your Promptive file, the next thing we did is adding it to a Python file because we want to take it to production, right? So we added it to Python. And in addition to now, you see, for the Promptive example, we gave it context. So, but now what we want it to do is we want it to use our own data for context. So we've added our Azure AI search, and it can be able to retrieve documentation. And then we added the question, the index name, and the embedding. And then down here, when someone asks a question, you see we've imported Promptive. And if anyone asks a question, we take the question from Promptive, and then we use the context the user has. And that's it. If I run this, it will probably give me the same answer, but the difference will be it's now giving me context. So its response, it's telling me this is the question, this is the embedding of the question, and then gets the index name, gives me the context, and the output will be what we see here, which is now the tent catalog page. I normally try and experiment with this. For example, probably change the language. So when I add in the tone, I can say reply probably in Kiswahili. And once I do that, I run this, then I can also come and run this. So the response will now change to responding in Kiswahili. Oh no, wait, has this run? Yes, it's been able to run. Mahema kutoka Kontoso. Hey. Safari yako ya ndani ya maumbile inaanza hapa. I guess it's supposed to be the journey inside nature starts here. I guess that's what the response is. And then, yeah, the last bit here is like giving you the call to action. It's light, it's carryable, it has a lot of pockets inside for all your tools. And then if you want to sleep on the ground, looking at the stars, you can do that with Contoso, and then it ends with get your tent today or now. Yeah, that's it. So basically, it's the same output that I was getting here. It's giving us the question, the generated copy, and the context used. And that's how you can simply create your AI application and have it use your own data. And then as I conclude, I mentioned about evaluation. Once you get in your questions and probably the output is not accurate or reliable or it's incorrect, how do you evaluate your model and ensure it's always giving you the responses you expect? So in evaluation, there are 2 ways you can do it. That's manual evaluation and automatic evaluations. So what you do when you're evaluating is you probably ask a question, get the output, and then evaluate the output, and then go back and try again. And we normally have different metrics. There's metrics for performance, there's metrics for risk and safety, and you can create your own custom metrics. For our case, we'll look at the metrics for performance and quality. And because of time, we'll use automatic evaluations. You can use manual evaluations, but it will take you a lot of time to be able to go in there and evaluate. Okay, there's a question, but I think I'll reply after this. And then you have automatic evaluations where you now use AI-assisted measurements. These are the different measurements that you can use. So for quality, we'll use this: groundedness, coherence, currency, and similarity. There are also other NLP evaluators that you can be able to code in there. Then the risk and safety and your own custom-built metrics. What these different metrics mean, for example, is groundedness is you've realized we added in our own data. So the question will be, how is the model output answers aligning with the input data that you've provided? So that's where groundedness comes in. Relevance is, how is the output that's been generated responding to the question that was asked directly? So that's relevance. Then coherence is about how well the flow is in resembling the human language. So how well is the output? How does it look like? And how is it? And then fluency is about evaluating the extent to which the generated text aligns to probably grammatical errors and any structures and vocabulary usage. And that's it. As I mentioned, this is just an illustration of getting the evaluation. So one, you have probably your data set, and then you have it go in there, get responses. This is using your LLM, and then you evaluate it, and then you get the evaluation from Azure AI Foundry. Okay, there's a question on chat. For example, when you uploaded a sketch, if one uses a sketch where part of the text is not fully legible, does it only capture the legible text? So let me go through that before I go into clear remote data source. Let me go into that, and let me add an image that is not legible, right? So this one. So if I ask AI, what is this? Even if I ask you, what is this? Can you be able to tell me, oh, I should have removed this context. Light changes, continue. Let me do it again. Hide. Can you be able to read really what is that without any context? So let me upload that image again and ask, what is this? And based on the output, it might not really know what exactly it is. So it's telling me it's a photographic paper and some areas that are obscured and redacted. So it might be a signature or a handwritten note, but it's like, I can't give you more details. So this is an example of if you give it a place where the sketch probably is not very legible. So it can be able to now go in there and now tell you, okay, can you be able to do this again and try it again and see if it's readable? So if I add in the same paper, but now with more context, example this, and ask it again, what is this? You will see the response is quite different because now it has additional information. It can see this is eggs, milk, steak, mayo, and so much more. It says, it seems like it's someone for a shopping trip, and yeah, probably the context now matters. Yeah, and that's it. So ensure you give it context that's enough. Even if the sketch, the handwritten note might not be legible, ensure it has enough context to be able to know, like, what exactly are you trying to create? And then the last question when you upload your own data, does it remember it and use it for future responses without you having to input it again? So in my Python code, I have asked it to retrieve documentation. This is a Python function to retrieve documentation. And then there's another response. This one. This is now, anytime a question is now asked, it now uses the get context, where it now uses the question and embedding. Basically, it goes through, retrieves the documentation, using the question and the embedding, and gives me an output. So this function ensures I don't have to repeat it again. So that's one example of using it. The other thing is, if you're building with agents, there's something called threads. And once you start a thread, it will still continue and use that context. And then the last bit is, yeah, this one, threads. So it uses that thread as a base of everything. And then the other bit is we used playground. The other thing is, one of the parameters is include past messages. This also gives it enough context. And then you see, for this, I haven't added my own data. So if I come in and add in my own data source, you'll always refer to my data when it's answering any questions. Yeah, that's it. Okay, so the evaluation. So again, I still use code, but it doesn't matter whether I use code or not. But the idea behind this was to configure my model. So you can see I'm using GPT-4 for evaluation. And I uploaded a dummy data set. So this data set has 3 questions. So I've also added in the evaluators for relevance, thoroughness, fluency, and coherence. So when a user asks a question, so now what I do last is evaluate based on the evaluators available and the data. That's the 3 questions I've added. And then it gives me like the mapping of the data query, the response, and the data context. So whenever I get the output, it will be probably the inputs query, the context, and then the response. And then it gives me an output of the relevance score is 5, and this is why it's 5. So if I go to Azure AI Studio, that's the link. Let me just click on the link. If I go to Azure AI Studio, that's the link I had opened earlier. You can be able to now see the entire table on Azure AI Foundry with now details of, for example, these are the scores that you've had. And you can be able to see in your data and see, this is the question, the response, the score, and then it tells you the response provide a well-structured detailed description of various tens. So it's at 5 over 5. And then for fluency, it's 4. So it's telling us it demonstrates coherence, making it easy to understand, but it's not very good. So it's still at 4. And then I guess everything else is at 5, meaning everything else is good. So yeah, that's it. You can be able to now see, okay, it's giving me this response, and this is why it's giving me the response. And then when you talk about groundedness, it also looks at the context behind it. So this is the context that was behind it. This is the data that was used, and then this is the response. So this is why, as you can see, it says it accurately reflects the information provided in the context for each tenant, including things like brand, features, and technical specification. That's it about evaluation. So what you'll need to, basically what you do is have a dummy data set. For me, this is my dummy data set, 3 questions. And then with these 3 questions, you use it to evaluate using the 4 evaluators, and then you get a response based on that. Yeah, and I guess that's the end of my session. And today I've covered about Azure AI. I've covered around models, which models you can use, how you can use benchmarks, and you can filter through the different collections to be able to see, oh, this is probably the model I need. And then I've also talked about model customization, how you can iterate and tailor your model. I've mainly dwelled on the RAG technique, that is bringing in your own data and being able to use that to now answer the questions. And also I've talked about using system messages to be able to now custom tune your output. And then I've also talked about evaluation, where now we're using another AI to evaluate our models and see if it's working as it should. And the last bit is, this is a recurring process. So every time you need to do it over and over again to be able to get the output that you request. Thank you so much. If you need any of the resources I've shared today, you can use either the QR code there or the link that, let me just paste in the chat, that you can use as reference. And I guess that's it for my session. I'll hand it back to Michael in case you have any questions.
Thank you so much, Bethany. That was a very insightful session. We'd like to thank you once again for sharing your valuable insights and your expertise. With your knowledge, you have certainly broadened our understanding of the potential and the applications of generative AI in the Azure ecosystem. I can see we still have a couple of minutes, so wanted to ask my question. With things, there's a lot of hype around things like DeepSeek in the news and the media. So just wanted to get an understanding from yourself. Is this something that is available on Azure? And is I think one of the other things that they talk about a lot is safety. So is this something that is safe to use on the platform?
So the good thing about models on Azure is we add in our own, can I say, our own prompt engineering to it in terms of adding in our own safety measures. As you can see, we already have like content filters you can use. So we try our best to ensure when we give you like a model in production, you can actually be able to use it in production. And yes, DeepSeek is available. I haven't tested it out, so guilty. So let's see. Let's deploy one. You see, it has content filter already enabled to it, and we're deploying a serverless API. Am I in the right region? I guess I'm using Sweden Central, so it won't work. Yeah, I don't think it will work.
Yeah, I think the question was around, do you still get the advantages of having those content filters when you're using any of the other modules that are not necessarily offered by OpenAI?
Yes, we do. So I don't know if this will work because I'm not sure which region I'm in. So let's see. I'm guessing it's working. Yes. And then, you know, the beauty of it is you can still add in more safety features to use in production. Okay, so I don't know which question is like the default question. If I'm traveling to Paris, what can I do in Paris? So probably I will get wings and fly to Paris. So I can ask, what can I do in Paris? And it's supposed to give me a response. DeepSeek takes quite some time because it's a reasoning model. So it might take some time to respond. But basically, it's available and you can use it in production. You can use it whenever you want to use it. Yeah, so it will respond eventually. I hope. I haven't used it before, but yeah.
Okay.
It has safety features. You can add in additional safety features in case you want it. Yeah. So it's now starting to respond. And then the other thing is the delay is mainly also caused because if you have a content filter in place, it might, like if a response is coming out and it's not the right one, it might like go back to the model. That also causes it to have a delay. Yeah, so the user is asking, what can I do in Paris? So they want to know activities and attraction in Paris. So what it will do is list the main tourist attraction, the Eiffel Tower, the Louvre, Notre Dame, and probably the Seine River cruises. And then they might also be interested in something. Basically, it's a very good answer.
Okay, that's a very detailed answer. Thanks a lot
very
for setting that up.
Yeah. So
Okay.
there's a question, which model does Bethany enjoy using most and why? There's one model, the real-time endpoint, there's the audio preview and the real-time endpoint preview. Those are the two models that I can say are very good for me. Not because I hate typing, but because it's like having a conversation. It's much faster and easier. So if I'm learning about some new concept, I can be able to use it. And you see the way you have like a colleague and you're like, "Yeah, I don't understand. Can you break it down?" Like you can have that conversation. If you feel like the AI is going away from it, you can just say, "No, don't do that. Let's try again." And then the responses are much faster, and you can even tune the voice you want to use and so on. So yeah, the real time is a very good one. The GPT-4o, the endpoint preview. I guess it's also available in ChatGPT that you can be able to use. It's also available in Copilot, I'm pretty sure. And then, of course, GPT-4 because it's multimodal and it's very easy to use in case you want to generate code. And then the last one, especially for code generation, is Cloud. Cloud is available in GitHub Copilot. So I've not tested Gemini, so I'll need to test it out and give you a feedback. But for me, currently, it's Cloud for the generation of code. So Cloud for code generation, the GPT-4o real time for conversations, and GPT-4o for anything else, especially in case I need to like chat and interact with the model. Yeah, I guess that's it. I haven't experimented with DeepSeek or O3 or O1, but they're very good at reasoning. Sometimes I use O3. This is a very wrong thing to say, but I normally use when you do word connections, the game, and I'm stuck, I'll just go in and use O3 and I'll use GPT-4o to get I'll take a screenshot, use GPT-4o to get the different words and then send it to O3 Mini for the responses. It's normally not very successful, but yeah, I normally do that as well for vibes. In case I want to play a game and I'm stuck, I'll just use O3 to help me solve that. Yeah, I guess that's for the models I enjoy using.
That's a very useful and insightful response in terms of the models. And I guess that kind of goes to show that you can use models for anything, whether you're playing a game or whether it's work, and it cuts across everything, across industries,
Yeah.
across different activities, and you can pretty much go in and make what you want. So it's almost the top of the hour. Would like to thank you once again, Bethany, for taking the time to run your session. Thank you everyone who participated today, and hopefully we have got some enlightenment on generative AI and how to use Azure AI Foundry.
Yeah.
We hope this webinar has inspired you to explore future possibilities and that AI, using AI and data. And our community thrives on collaboration and continuous learning. So we encourage you to apply these insights, go into Foundry, try playing with the different models, trying to see what works for your use case. And like we said, it goes from your business processes all the way to your social or different scenarios. So thank you once again for your active participation and enthusiasm. And we look forward to seeing you at the next webinar. Thanks again, and bye-bye.